Okay, first of all, Happy New Year, everyone. Thanks for joining. So, today I'm going to discuss a EVPN multicast high CPU issue. This was one of the campus cases that we got from a Sydney customer. They were facing the high CPU issue for quite some time since they implemented the EVPN multicast solution. It was due to different issues at each time. So I'll just walk you guys through one of all of this. So initially, the problem statement was this: the CPU was consistently high on all the leaves wherever EVPN multicast was involved on the 720XP, and so they were monitoring it using CVP and also their NMS. So once we checked the output of show proctop, then we found out the best manager is the one that is responsible for high load average and is at 94, around 90, almost all the time it was around 85-90% of the CPU. In all their problem statements, the common statement is that in all their previous cases also, the common point is that best manager is the one that is causing high CPU. So now what is best manager? So a quick brief about best manager is that usually to populate our PIM table entries like the mroute or the mfib entries, all of these we usually rely on the Linux kernel. So based on the Linux kernel itself, we populate the multicast entries and also we set the flags once we send out the traffic or receive the traffic based on the Linux kernel. So the problem with that was we used to send out the packet first and then populate the entries or the flags. So that sometimes could lead to a bit of a time mismatch, and there is a race condition. So for the other agents who are actually dependent on these flags. So to avoid that, we came up with this. Best manager agent, which instead software forwards the multicast data packets. So this is configurable from the CLI, and this is the configuration for this. So this is for IPv6. If IPv6 is not there, you can just remove this step IPv6, and you can just use the software forwarding SFE. If at all we are using IPv6, we also need to explicitly enable the IPv6 unicast routing. So now, firstly, when they opened their first case, right, we verified all the possibilities why the multicast agent is high, if there are any missing routes, if there is if there are any missing interfaces like the null interface or anything. But nothing was found, and it was escalated to engineering, and they noticed it was a bug with SFlow. When you have both SFlow and EVPN multicast configured, the agent incorrectly polls the data and captures the multicast also into the SFlow destination. So that was why this bug was found. There's not much to debug about this. Secondly, when second time when they opened another case reporting high CPU, we found that they were running this version, which is EVPN multicast .1. This does not support MLAG. So after escalating to engineering, then only we discovered that this does not support MLAG, and the customer was using EVPN multicast with MLAG. So then they had to upgrade to 4.27. So that is when the second time the issue was resolved. So third time when they reported, they were not encountering the SFlow bug because they already removed the SFlow configuration, and they already moved away from this version to 4.27, and still they were seeing the high CPU issue, and the best manager is again at 90-85% CPU almost all the time. So then we check the multicast queue, the show CPU counters queue output, and we see the drops are huge and they're continuously incrementing throughout the history tech. So as you guys know, right, in any multicast uh, network, the reason the multicast miss counters increment is because you do not have a route, you do not have an entry for that to feed. So that is when you're getting an unknown feed, but you do not have you're getting some feed from the sender, but you do not have the relevant entries or any of the routes program. That is when the traffic is going to go to the multicast miscue. And beyond the point, if the traffic rate is too much within a given period of time, the multicast miscue drops are seen. So now in this specific case where EVPN is involved, when can we see the multicast miscue increment? So it can happen for two reasons. One is the overlay MRoute not being programmed in the hardware, and the other is the underlay MRoute entry that is not being programmed in the hardware. So just some quick background on the EVPN multicast. So how this works is usually in the normal unicast VxLAN, we have some traffic, the bound traffic, and we encapsulate it with the unicast header. That means the source and the destination are the unicast IP addresses. But here we have the destination IP also as the multicast. So that's the difference between the uh, unicast VxLAN and the multicast VxLAN. So for this to work properly, right, you need the entry for both the outer destination and also the inner destination. So the underlay is called the outer destination, whatever we configure manually under the VxLAN configuration, right? Like the unicast floodlist, we also have a way to configure multicast floodlist. So that is what is called the underlay MRoute, and overlay is the traffic feed, the internal packet, the inside destination, right? That part is called the overlay. So if any of these are missing, the traffic can go to the multicast miscue and it can get dropped. So yeah, for the underlay, the traffic can be missed if the traffic is being received on the core ports. That is, if you're getting a VxLAN NCAP traffic on one of your ports facing the core on one of the leaves, and if the relevant hardware entry is not present on the leaf, you will send it to CPU. Because you do not because you do not have the route, you'll send it to CPU, which in CPU it will just go to the miscue. And why do we not why what are the possible cases when you do not have a overlay M route? So this can be happening when you have traffic that is ingressing from both edge and core ports. So when you have the traffic that is ingressing from the MLAG pair leaf and also from the core, and if the relevant overlay route is not programmed, that is when it can go to the multicast miscue. So we verified on the customer Showtech, and we found that the underlay route is programmed fine. So this is the multicast address that was used for the underlay, and this is programmed fine as seen. So this can be seen in the show interface VxLAN1 output. You can see that this is programmed. So now our next step is to examine if the overlay route is not programmed. To see that, we took a TCP dump on the core ports to see if we are getting any VxLAN NCAP traffic and if it's going to CPU. So once we got the TCP dump on the core ports, we see a lot of traffic with the outer header as this. As we discussed, we'll have two IP headers in this VxLAN packets. So the outer header is as expected, 121, which is programmed fine. But we see a lot of packets with inner multicast headers, which are going to the CPU. So to filter for that, first we filtered with the, I hope you can see my Wireshark screen, right?
Yes, yes. Okay.
Yeah. So first we filtered with the UDP VxLAN port, and then we added the outer source and destination. So based on this, we can see there are so many. So all of this is the multicast destination traffic that is inside the VxLAN packet. So there is lot of VxLAN encapsulated traffic that is being received on the core ports. So all of this is going to CPU. So now our further step is to understand why is this going to CPU. How are we able to identify that this is the one that is causing high CPU, or that is going to these are the packets that are going to CPU, is using the VNI. So inside in the packets we have the VLAN to VNI mapping, and using the VNI mapping we were able to find out that it is 520. The VNI is 100520 and the corresponding VLAN is 520. So since we have so many, we just sampled one of the internal destinations, the inner headers, and then we checked in the Qt logs. So the latest Qt logs were seen just on November 8th. The case was opened a week after November 8th. So there is no activity since November 8th for all these groups. There's just traffic that is incoming, but there is no group creation or there is no route change or any of that sorts happening. So we don't know if the so from this it is clear that there is no route changes or any of the mroute programming that has happened recently. So now we suspect that the PIM-SM did not create a null SG route. So for any unknown feed that you're receiving, right, once the entry hits the CPU, you create a null SG route so that the further traffic does not hit the CPU, and a fast drop rule is created. So basically, it's just saying that, hey, I already received this unknown feed. So I do not have checked the mroute table. I do not have any entry for this. Let me install a null route so that so that the relevant agent can program a fast drop route so that the traffic is dropped even before hitting the CPU. So that is how we are offloading CPU from all this unnecessary multicast traffic. So here our suspicion is that the PIM SM agent is not creating a null SG route so that the platform can install fast drop entries. But why is the case? So then we verified the underlay route. So this is just the show IPM route on the VTEP, and then we found out the outgoing interface is VLAN 520. So as discussed before, this was our PIM VLAN 520. So this is seen as the OIL. But in case of VxLAN multicast, we do not see the actual VLAN in the outgoing interface list. What we have to see is the dynamic VLAN that is being created, that would be created, which is 4094. It changes depending on the number of entries you have, number of VLAN mappings you have. So this is a dynamic VLAN that gets created, and that is supposed to be in the outgoing interface list. And once the traffic comes here and notices the outgoing interface, then further it understands this has to be decapsulated, and then further it will be routed into the relevant var for the VLAN. So that has to be the entire traffic flow. But in case of customers output, we notice that it is VLAN 520, which is the actual VLAN. So the unknown traffic will come here and notice that the outgoing interface is VLAN 520, and it will check the IGMP groups detail. As you can see, the only member part of VLAN 520 is CPU. So that is why the traffic is going to CPU. So now, why is the outgoing interface incorrect? Why is it not 4094 and why is it VLAN 520? So this it is when the devs requested us to do a lab recreate. So firstly, the 720 XP switches in the lab are very limited. And even though we have a couple of 720 XP switches, we do not have multiple other switches that are connected to it. So we had to shrink the topology a bit. So as you can see on the diagram here, ROI 457 and ROI 456 are the 720 XPs that I used. Usually in a VxLAN environment, what we expect is we have leaves here and then we have a spine also here. But because there are no more connections where a device is connected to both of these, I just used a direct L3 link here, which is ET1 connecting to each of them. And here we have the sender and a receiver. So initially, I just used the same config that the customer had, and we tried to check if the fast drop is configured. So the command to check if a fast drop is present is this: show platform trident L3 software mroutes. So in this, you can see there is no entry for the group that we are interested in, which is this one, 250. Sorry, which is this one, 224, 255, 029. So for this inner destination, there is no fast drop that is being present. So that is why the traffic is going to CPU. Once we reported to the dev that the issue was replicated in lab as well, they noticed that this command is missing in the customer's VxLAN configuration, which is VRF2 multicast group configuration. So what they initially had was just a VLAN to VLAN to multicast group. I think I did not add that output here. Let me quickly show you on the case. Yeah. So what they initially had was this configuration, which is an individual mapping. For each VLAN, they had a multicast group configured. But what is expected is that a VRF specific multicast configuration. Now, what is the need for this VRF specific multicast configuration? This is because if you notice the VLAN here, right? The VLAN 520 here, it is a L3 VLAN. That means it has an SVI and it also has the PIM neighborship involved in it. So for every for every L3 VLAN, we expect a L3 mapping present in the VxLAN as well. So that is why we need the command VRF. We need the VRF to multicast group specific command. So once we added this command, we could see the fast drop for our specific target group is formed already. It is installed. Uh, while checking this, one doubt that I had was, even though this is a fast drop route, why do we see that the fast drop flag as N, which is no? So the reason given is that our platform, the Trident platform, considers a entry to be a fast drop entry only if there is a RPF failure. But in our case, there is no RPF failure type. The fast drop is the fast drop is present because there's no receiver present. So that is why this platform does not flag it as a fast drop, but it is actually a fast drop rule that is present. So once this is in place, we can see the traffic is no more being punted to CPU and the CPU usage has reduced. So another interesting observation that was found was that while I was trying to replicate the solution that was provided, as in while I was trying to add this command in the VxLAN interface, I noticed that the fast drop entry was created, but still the traffic was going to CPU. So when we reported this, again the devs found that due to a race condition. So I initially had the VLAN to multicast group command, and then on top of it, so I removed that and then added this command. So due to that race condition, the underlay entry is a bit messed up. So the entry here is shown as -1. Usually it should have a couple of it should have a normal number, and it should have the hits incrementing. So that is our key. It should have the hits incrementing. So the workaround is that first add the VRF command, then remove the individual VLAN to multicast group command. So that is the workaround provided. So that was the learning from this case, that for every L3 VLAN, the VRF to multicast group command is mandatory, and this command is not mandatory. This is optional. So due to this, the customer was facing high CPU issue. Are there any questions?
Can you explain about that dynamic VLAN concept? What was that? That was not clear.
You mean the 40941, is it?
Yes, yes.
Yeah.
Um,
So yeah, so once we have such mappings, right, let me just show you a quick article on this one. So this is one good article which can help us understand all the various scenarios in EVPN multicast and also the relevant outputs. So this is the one that helped me work on this case as well. So whenever we have the VxLAN mappings like this one, VRF mappings, VRF to multicast group or the VRF to VNI, we have the dynamic VLAN associated with, because we do not have an individual VLAN mapping for the VRF. We have a dynamic VLAN that will be created automatically by the EVPN. So that will be populated as the OIL here. Yeah, so that has to be populated as the OIL here, which is 4094.
okay.
I actually wanted to give
Yeah.
the lab demo. Unfortunately, one of the devices went into a boot.
Yeah, just to add on what Srilekha said, right, about dynamic VLAN. Um, so the reason for creation of dynamic VLAN is that our switches by implementation only understand VLAN to VNI mapping. So a VNI must be associated with a VLAN. So now, so we are associating an entire VRF with a specific VNI. So internally, what the switch does is it does not know to map VRF to VNI. So internally, it is going to create a dynamic VLAN. So typically, this is chosen. I mean, we can configure it. We can configure the range of values that switch needs to take for dynamic VLAN. But otherwise, typically these VLANs like 4094, 4093, these are usually these are the ones that are configured. So it's just an implementation thing. The VLAN to I mean VRF to VNI mapping, uh, uh, rather than a technical thing of EVPN itself. It's more of a implementation on the RST side.
Okay. But usually, let's say in MLAG, right? When you
Mhm.
configure MLAG, most of the times you define the MLAG peer link in VLAN 4094. So if you do that, and if this dynamic VLAN also is 4094, then will it like collide, or will some loop or some any misfunction will happen?
As far as I know, it is not going to choose the one that is already existing. But if you run the command show VLAN as well, right? This is going to be a new VLAN which will be created in the given range, and that is going to have a star mark as well when it's created. Not sure if we can show that.
Yeah, I have one device active, so on this
Okay,
the output should be there. Yeah.
so this is how it's going to look like. It's going to be a star, uh, indicating that this is a dynamic VLAN.
Okay.
So another question that I had when devs were giving this, when the customer actually reported this issue, and I was discussing with Aniket. So we had one more question. So how is it possible that unknown feed can come on a VTEP? So it's not like the general multicast, right? So whenever only if there is a subscriber, only if there is a receiver that is subscribed to it, only then the VTEP will join the overlay multicast tree, which is the show IP mroute output that I showed you earlier. So only then this VTEP's entry will be present in the OL of the other mroutes, and only then it should receive the traffic. So there is no way that the unknown feed could be received by a VTEP. So that is when the devs replied that, so even though the inside groups change, the outer header is always same. So the outer destination is always same. So once, let's say this has a receiver for a different group, not for 224, 255, 29. Let's say the receiver is for 28. So it will definitely join the overlay. It will definitely join the overlay multicast tree. So now even if you get some traffic, even if any of the VTAPs get traffic for .29, the VTAPs will simply flood the traffic to all the VTAPs that are part of the overlay multicast tree. So you need not have a receiver that is specifically for this group. But even if you just have any receiver, you will be subscribed to the overlay multicast and you will receive all the feed, which is not optimal. Yeah, that's just one point I wanted to add. That's all I had. If there are no questions,
Thanks, Shrika. Stop the recording. I think that's it we have for today. And if anyone would like to present a case or any QIs, please do reach out to Vijay or myself or any of the leads so that we can schedule accordingly. We'll probably have more refresher sessions in the coming weeks. And yeah, we did have multicast training, and during the team meeting, we had concerns that some of us couldn't attend the training as such. So if anyone would like to review the multicast refresher again, please do reach out to me so that we can schedule it accordingly. I think that's it from our side. Thanks, Srileka, for doing wonderful presentation and a great. I mean, this was a great start for the year. Thanks a lot.
Thank you.
Thank you.
Thanks, guys.
Bye-bye.
Thank you all.
Thank you, guys.